Hi, today we will be doing the test paper 1, session C. So we will do the question from 9 to number 18. Question number 9. Student faculty feedback data may suffer from issues like accuracy, completeness, and inconsistency. Discuss each issue in this context. Example, missing survey responses, contradictory ratings. Propose two other dimensions of data quality relevant to learning analytics. The answer is core quality challenges, the dirty data issue. Accuracy, truthfulness. Definition: does the rating reflect actual teaching quality? The issue is subjectivity and bias. Example: a student gives low ratings solely due to poor grades, known as grade bias. Completeness, which is missingness. Is the dataset whole? Issues is non-responsive bias. Surveys are voluntary. Often only the very happy or very angry responders, distorting the averages. The consistency, which is logic. Do data parts contradict each other? The issue is conflicting signals. Example: a student writes great class but clicks 1 out of 5 by mistake, or rates content poor but overall excellent. The timelessness, value of time, why it matters. Feedback values decays rapidly. The goal is an actionable state. Example: week 4 pulse check allows intervention. End of semester feedback is too late for current students. Question number 10. Handling missing student feedback values. Discuss approaches such as ignoring tuples, filling manually, filling with constraint, mean median mode imputation, class specific imputation, or most probable value methods. Missing data. Example: skipped question is common. We must choose a strategy based on the volume of missingness and the importance of the data. The first will be deletion strategy. Ignore the tuple or delete, discard the entire student record. Use when missing values are rampant in a specific record. Example: empty survey or the data set is massive. The risk would be a significant data loss. Introduce bias if meaningfulness isn't random. The second would be a simple imputation, fast and rough. Fill with global constants. Replace or missing with NA, unknown, or -1. When we use it when you want to explicitly flag the missingness in analysis. Or we can do the mean median mode, which is replacing missing numeric rating with the global average or median value of the dataset. We use it when data is nominally distributed. The risk would be to reduce variance, mask the feedback look more average than it is. Question number 11. Consider the feedback ratings. Smooth the ratings using bin means with depth 3, illustrate steps, and suggest ways to detect outliers, and discuss other methods for data smoothing. So subsection A is smoothing by bins means of depth 3. So bin depth is equal to 3 means we partition the data into bins of 3 items each and replace values with the bin average. The step 1 would be to input data sorted, which should be sorted. The sorted data looks something like this, and the total is n equals to 27 items. Step 1 will to partition into bins of size of 3 and calculate its means. The step would be to replace value, smooth the data, so the three the three value bins would become two and one value which is 20.64 and something like that, which for 27 times, and so on for all the bins. Subsection B, outlier detection methods. So the method 1 is a block spot analysis, the IQR rule. Quotient 1, which is 25th percent, which is 20.5. Quotient 3, 75%, which is 35. IQR rule which state with 35 minus 20, which is 14.5. The upper fence will be quintile 3 plus 1.5 into IQR. Would be 56.75. Result: the value 70 is greater than 56.75, so it is an outlier, and any value greater than 56.75 would be an outlier for the dataset. Option C, other smoothing methods. So bin median replaces bin values with the median. Example: bin 9 median is 52, which is less affected by the outlier 70 than the mean 56. Bin boundaries replace values with the closest boundary, minimum or maximum of the bin. Clustering groups similar feedbacks into cluster. Example: lower, medium, high, and replace with centroids. regression. Fit a curve to the sorted data to capture the overall trend. Question number 12. Use the Tech analytics. Discuss scheme integration, handling redundant data, example duplicate entries for multiple surveys, and resolving conflicts in values. Schema integration, the entity identification problem. The issue is uh, defining databases often use different names for the same context. Uh, for it, we can see the source A uses student ID and source B, the tool uses roll number. So there are two different things referring to the same uh, uh, attribute. The solution would be the metadata analysis, compare scheme definition, data types, field length to map equivalent fields. Entity resolution. Use heretic matching. Example, if name plus email matches, then student ID and roll number refers to the same entity. Handling redundant data, the duplication problem. The issue is the same attribute or tuple exists in multiple places or attributes can be derived from one another. The context would be a duplicates. A student submits the feedback form twice, once via mobile, once via web app. Derived data. The dataset contains both date of birth and the age. The solution would be the correlation analysis and duplication. The correlation analysis will be a detect redundant attributes using person's correlation R for numeric data, example CGPA or grade points, or using the chi-square test for nominal data. Duplication would be keep all only the records with the latest timestamp or the most complete fields. Question number 13. Discuss normalization method, min-max normalization, few-size normalization, few-size normalization using mean absolute deviation, and the decimal scaling. Min-max normalization. Rescales data to a fixed range, usually from 0 to 1. The effect is preserve the original distribution but changes the scale. The use case are algorithms requiring bounded input, example neural networks and KNNs. The formula is x dash is equals to x minus x of minimum, x maximum minus x minimum. Subsection B, z-score normalization or standardization. Transform data so that it has mean equals to 0 and standard deviation of 1. Effect. Centers and scales data. Handles outliers better than min-max normalization. Use cases distance-based algorithms, k-means, PCAs and regressions. The formula is z equals to x minus mu divided by whatever the standard deviation. Z-score normalization using mean absolute deviation MAD. Similar to z-scores but use mean absolute deviation instead of standard deviation. The effect is more robust than standard z-score because MAD is less sensitive to outliers. The use case is data sets with extreme values or heavily tilted distributions. The formula for this is 1 by n into summation of vi minus u. Decimal scaling normalization. Move the decimal point of value so that they falls within 0 minus 1 to 1. The use case is simple data sets where scaling based on order of magnitude is enough. The formula is v dash is v divided by 10 to the power of j. The question number 15. Using the feedback rating dataset, normalize the value of 35 using min-max normalization and z-score normalization. So the using min-max normalization of z to 1 range, we know the formula which would account to 35 minus 0 divided by 50 minus 0, which would do nothing but an approximate value of 0.70. Subsection B, z-score normalization. We would be using the z-score normalization formula, which is x minus mu by standard deviation, which is equals to 35 minus 12 divided by 4, which would account to 5.75. Question number 16. Explain which smoothing method is more appropriate and why. The smoothing by bin median is the most appropriate smoothing technique. It reduces noise effectively, preserving the central tendency better than the bin mean on boundaries, less sensitive to outliers than bin mean, ensures respective smoothing for skewed or unevenly distributed data. Question number 19. Use a wrapper-based summarization attribute selection technique for feedback analysis. For forward selection, backward elimination, and hybrid method. Schema integration, the entity identifier problem. The wrapper method evaluates subsets of attributes by actually training a predictive model. Example decision tree, SVM, logistic regression, and selecting the subset that gives the best performance. We apply wrap-based selection to feedback analysis attributes such as rating, attendance, interaction levels, submission punctuality, feedback length, and demographics. So subsection A, forward selection. We start with no attributes, add one attribute at a time, the one that improves the model uh, accuracy the most. Stop when adding more attribute does not improve performance. Simple and effective and data sets have more irrelevant attributes. Best when starting with minimum subsets and building upwards. Subsection B, backward elimination. Start with all attributes. Remove the attributes who reduce model performance the least. Repeat until removing any more attribute worsens performance. Good when you accept more attributes to be important. Works well for small datasets. Subsection B, hybrid method, which is forward plus backward method. Combine both forward selection and backward elimination. Begin with forward selection until performance plateaus, then perform backward elimination to remove redundant attributes. Balance the risk of adding irrelevant attributes from forward and removing useful ones from the backward. Reduces the minimum accurate high quality subsets.